Welcome. So every one of you who has not scanned this, if you want to participate, scan this. And you should see a question basically asking you how you feel, just a slider, and then you can participate. And thanks for coming. Thanks for coming to apparently Paul de Bevic's substitute teacher. Thanks for scheduling, Chris. Today is weirdly titled Teaching AI How to Speak Houdini. I'm just basically going to talk about a bit of AI stuff that's been, that is nice, that's been developed over the past few weeks, and how we can integrate that into Houdini. Okay, and I'll have questions interspersed throughout the whole presentation, just to get your opinion on stuff, because this presentation is also for me kind of a chance to get your opinion on generative AI in a Houdini context and an industry context, and that's kind of important to me. Hi, welcome, guten Tag. Thank you so much for having me, Chris. Again, not a talk about speech recognition or speech synthesis, a talk about AI, generative AI for 3D generation in Houdini. For that to start with, I would love to hear your thoughts or experiences with AI. So are you relaxed about AI? How do you feel about it? Do you feel comfortable using it? Do you think you have a decent understanding of what's going on under the hood in AI tech? Do you think it's useful? And do you think it's here to stay? So let me know. Okay. That is cool to hear. Especially about the top one, I was a bit torn. I was a bit worried about what you'd say there. Come on, go on. Yeah, especially about that here, I'm kind of... That's more than I expected, actually. That's good. Yeah, I agree with that one. And I partially agree with that one. And I definitely agree with that one. Oh, with that one. Okay, cool. The joke or the thing that Manu and I often talk about is, my theory is the worry about AI gets a bit like this curve. So you know nothing, you're not worried about it. Then you know a bit about it, then you're shit scared. The more you know, the less worried you are. And then suddenly you know stuff and you're worried, but for other reasons than at the beginning of the curve. And I think I'm here. And I would like to get you in that zone as well. So either get your knowledge up to that point or dumb you down to that point. With that, this is about Gen AI. So tell me a bit, God damn it, that just started. Yeah. Tell me about if you've used AI, generative AI, personally, professionally, and if specifically you've used Gen AI 3D generators for mesh generation or for 3D content generation. Okay. Honestly, about what I was expecting so far. Okay, great. Which tools? God damn it, Menti. I'm pushing it here. Using PowerPoints with plugins. This is just like your ranking. You just rank what you've been using so far, what you know, what you might not know. And this is really intriguing for me because that's kind of a wild one. Okay. I am glad to inform you that, of course, what I've chosen for today is your fourth choice, which is what I was expecting. So this one is kind of surprising. I'm seeing that with my students as well, and I get into that in a second. I'm seeing that with my students currently as well, and it surprises me that that Midjourney isn't there by far in the first place. All right. So talk out today is AINP. What does that mean? API. A totally vibes-based approach to life and living with AI. So basically, we are doing AI APIs in Houdini, or how I learned to stop worrying and love the prompt. This is kind of my toy setup, generating vintage handheld consoles of a certain brand. And before that, to those who might not know me, this is me, yours truly, Moritz Schwind. I'm now a professor at Nuremberg University of Applied Sciences. I'm a co-founder at Entagma. And the thing that gets me most proud and revved up is I'm a PhD candidate now. This is super exciting. And I do generative AI, generative design, and mainly Houdini and Python. And kind of my origin story is I come from classic commercial work. So that's kind of my portfolio roughly 8 to 10 years back. lots of CG AI commercials for lots of sportswear brands. That was about the time when motion graphics integrated more and more VFX techniques, when we also started using Houdini at a small boutique studio in Munich called Expansa. And out of that, we founded Entagma, Manu and I, my partner in crime. We do tutorials on generative design, roughly to speak, mainly in Houdini. Nowadays also a few other tools. And then some time ago, I became a professor, again, down there with the weird teddy bear. You see me and Manu, again, my trusted partner in crime here, who's also a professor at Nuremberg Tech. And this is the kind of stuff I did like 2 years ago. That was my first proper foray in generative AI. So that's Stable Diffusion and trying to push it into areas where you typically don't get with text prompts, or that's kind of hard to describe by text prompts. And that's also what I'm researching now as a PhD candidate, when I'm not building absolutely shitty tech to get AI somehow to crank out images. I'm working with this, my PhD supervisor at Coimbra University, which is in Portugal. And I've got a research project with a bunch of Barcelonians who run a supercomputing center that some of you might know out of some sci-fi stories. Just to give you a quick intro, this is the kind of research we're doing. This is a point cloud, a cluster of concepts. So basically, and I'll zoom in into a certain concept, and you might see what it is. So that is, once I activate the visualizer, that's the weed cloud. So basically, your generative AI internally builds this high-dimensional space, which we've visualized here as this three-dimensional universe. And it kind of clusters concepts together in a way that it tries to make sense out of them. Zooming back to another cloud here, and I think this is kind of the book, librarian cloud here. And we're trying to navigate these clouds. And specifically, we're interested in these in-between points. What's in between those individual points that cannot be described with human language or with text. Which comes to knowledge generation. And I'm not sure if you've seen that meme. So this guy clearly says there's a linear dependency of, let's call it experiment and knowledge gained. It's your feeling about how does knowledge gain work. And the more I try to gain knowledge, the more I verge to one of these solutions here. the none of these, explain, just shout to me, explain, tell me. Please, the none of these, tell me why, tell me what's your theory, just shout if you have a theory. Why none of these? Come on, you clicked it. I'm not taking this personal, you clicked it. Okay, actually I'm with you, I'm with option 3. I think knowledge is this. You hustle a lot in the beginning, then you find out quickly, and then you hustle a lot to progress in your knowledge. So, before we finally get into the meat of this, usual disclaimer, opinion's my own. What worked for me might not work for you, and rambling white middle-aged man, so lots of privileges apply. Take with caution. What do I have here? Oh yeah, I love doing these tasks. Please. Seriously? Yeah, that's more like it. Yeah. Okay, I think I found my audience here. I would be interested to see how a typical VFX audience in one of these big production talks would react to this. But yeah, I'm absolutely with you. So none of these is particularly fun or particularly inspiring, I think. So let's try and automate them away. So the game plan for today is, let's take an input prompt, again, text, turn this into an image, turn said image into a 3D mesh, and then apply textures to it, with the ability to take any data we generate in between and modify it. So of course, modifying text super easy, but also we are not going from text straight to mesh or text to straight to textured mesh, but we can take any image in between or any mesh in between, modify that, mingle with it, and then wire it into the next step to be able to highly customize what we're doing here. So let's talk about these individual steps. The first thing is prompt to image. Basically, this is the easiest, straightforward, best explored step in here. You use whatever works for you, and I'll go about one certain model. You use Flux, Stable Diffusion. You can use just a GPT prompt and load an image in there, but you can also just take a photo or a sketch. Basically, it doesn't matter. As long as you get a square image of roughly 768 or 1024 pixels squared, you're good to go. That's fine. In here, I would have loved to use Flux. However, my machines I was testing this on was a bit too wimpy for that, so I went with this fine-tuned RealVis XL, which is a Stable Diffusion XL fine-tune. Just download it from Civitai, the home of not mature content, Then we're going image to mesh. And I've got few options here. Again, if you know that, and if you don't know that, doesn't matter. What do you think is best if you know them at all? And I have no clue if you don't have no clue. That's absolutely fine. Why Hunyuan? Because you know it, or because you've tested it? Just a gut feeling, why Hunyuan? Just someone yell at me, please. Heard of it? Okay. Used it? Better, okay. Compared it? Anyone? Okay. So in my comparison, i3DGen. It's really new. I think it came out on March 31st. It, in my opinion, produces superior, let's call it detail in quotation marks. Because although they like to speak of extremely high detail, and again, these are images from their publication, so they always feel kind of cherry-picked. In reality, there is higher detail, but not extreme detail. So that's what I'm sticking with. And then we do mesh to textured mesh, which is a procedure called MV adapter, which basically takes in a single image and a mesh, and then generates multiple viewpoints out of these. Typically, we want to produce 6, and we just do a projection, like a cube projection, back onto the respective mesh. All right, let's talk about implementation. The pain is real. The pain is real because of this. These are your individual models that we sequentially load. So we're starting with text to image. In our case, we're using Stable Diffusion XL, 8 GB. It's fine with most graphics cards. Can be more expensive when you're using Flux or the newer models, for example. And then we're going to go into image to mesh and texturing. I want to run these locally to be able to modify my AIs, my networks, and also to be able to guarantee that no data is flowing outside of my facility. So, question here is, oh, already answered. Can you still access it, although some people answered it? Okay, cool. Yeah, that's what I was expecting about. That's typically also what we see within our students or within our facility. Most of them the 12 to 24 GB range. Few cards are bigger, but basically these are your cutoff points for your models. So typically we have either the 4070s at our facilities or the 4090s. So with the 4090s, smooth sailing. With 4070s, most of these models won't fit in here. That's an issue. Especially if you have 49s or if you happen to have 4090s, super cool. You can fit them in one GPU, one model. But we're running 3 models. So what do? Well, you could load those sequentially. Loading the first model, 24 GB, goes up to your GPU, generate an image, you unload the model. You load the next model. That takes forever. It's like a minute or two to initialize those models to the GPU. So it takes forever. You don't want to do that. So the plan is here, instead of running those sequentially, let's run them in parallel and keep them running. And keep them running as kind of server processes, similar to a web server or to a computer. And you just tell them a command, please generate me an images, please generate me a mesh, please generate a texture. In my case, what I built up is these 3 components run on my workstation. It's got 2 GPUs. One is running the text to image here, so that's my small GPU with 16 GB, and one is running the larger one, the 4090 here. That's my mesh generation. And Houdini just sends commands, please generate an image, please generate a mesh out of this image. It gets funky when we do the texturing, because that's someone else's workstation. And hopefully my assistant isn't working when I use that, because that's her workstation, which has got a 4090 in there as well. And I'm just pinging this over our local network. So basically, we're having 2 virtual servers here in one machine and 1 proper server in the other machine. Let's talk about implementation. This is the good. This is easy. Text to image, especially if you're working in the 4th popular model, is like these 4 lines. You import stuff, you set up the pipeline, you send it to your graphics card, you enter a prompt, you generate an image. Smooth sailing. Super easy. That's what I do with my students in the first semester. Now, we need to add that server part so we can ping it. Vibe coding. It's literally, please add fast APIs to this code. It's kind of important that you know that the relevant library is called fast API. Otherwise, ChatGPT tries to generate like a Thomas Mann novel of code that does not work. In this case, it's rather compact. You take that, you run it in a Python environment, and you're done. That's fine. That's the good. Image to mesh is still all right. You're doing the same thing. You're installing a bit more complex. Your high 3D gen, again, recently released, like on March, really fresh, but it works. And then again, you add API support to it, and you run it. The downright ugly is texture to mesh. So that's the MV adapter. And I spent one full day trying to get this run locally, and I just failed. Couldn't get it. So what do? Do you bang your head against that invisible wall again? Or do you change gears? I changed gears and went to Hugging Face. Whose of you has used Hugging Face? Few? Okay. Okay, cool. So Hugging Face is kind of a hub for 3D models and demos for 3D models. Basically, they run demos for all of the relevant papers that have been published in your browser. And typically what they use, and the interface always looks like that. If you see this orange button here, you know you're running a Gradio interface. That's the library used here. I want to point out that up here, when you're logged in, you can check Run Locally. And what this will give you is this terrible command, which is a Docker command, which will take your stuff and run it in a virtual machine. So layers and layers of abstraction. Heard you like abstractions, right? So add abstraction to it. Don't want to go into Docker? You can just click this link, which will get you to this page, done by my dear friend Paul Ambrosiusen, who goes into setting up Docker for Houdini artists to run their own neural network on their machine. It's really convenient because most Docker images come just pre-packaged with everything you need to run. No configuration, no setup, no nothing. That works. Okay, so now we got Docker running. Now just modify the demo app. Let's try vibe coding again. What is your gut feeling about vibe coding that stuff? I like your optimism. Took me 6 hours. It's 6 hours of bug fixing, rather broken code, until it works at some point. So vibe coding, for me, the vibes change. But finally, it's Houdini time. So let's call some APIs. Again, I think this is one of about the last screenshots of just ugly text. But basically, once you set up everything, this is the line where you just tell, in this case, I think the image to mesh thing, please take an image in, spit out a mesh. It's literally the single line in Python, and then it starts cranking in the background. So the Houdini setup looks a bit like this. Again, Python node here to set up your image inference. I'll show that in a moment in a video. Generates this image out of here. Now, this is after my node that generates the mesh has cooked. We can talk about quote-unquote high detail meshes here, but and then you go about texturing. Again, texture generation and back projection, and then you're trying to turn these UVs into quote-unquote good UVs, and this here is Paul Ambrosiusen's 3-node recipe for auto UVing in Houdini. So basically UV auto seam, UV flatten, UV layout, and you went from whatever this is to whatever this is, which makes at least a bit happier. And then the downlight, most time-consuming part of this whole thing is not the inference of the mesh or the texture, is the reprojection of the textures after we've done the UV remeshing. So side effects, guys, feature request, faster baker. In SOPs. Once we baked all this, let's add a bit more high-frequency detail. So this is just my color map. And by making it black and white and blurring it, once with a tiny radius, once with a bit larger radius, and then subtracting, you get these faint outlines where we have like edges, high-frequency detail, and you can just use those as a fake bump map in your rendering. You put that into Solaris. You put that into Solaris and render it. That's just my material, and you can see a bump map goes in here. All right, shouldn't this play? No. Shouldn't this play? This should play. So there you see the thing. Just modifying my prompt to specify a classic Sega handheld gaming console. And then this is sped up by twice the time. This is the image generation. The high 3D gen, I think it's sped up 4 times. So not great, not terrible. Then you get your mesh here. If I enable proper shading, you might be able to see a bit more. Yeah, there you go. That's your quote-unquote detailed mesh. And then you trigger the texturing. And I cannot show you that because that's running over the network. So I'm just showing the network transfer here. And that was running at 4 times the normal speed as well. And now this is running at 10 times the normal speed. This is the reprojection workflow. And then you go there. And that's your quote-unquote high-detailed mesh coming out there. Again, the texture here, just going from the diffuse to the bump map. And that's the whole process in here. And again, I want to stress that the reprojection workflow was a slow part here, not the mesh or texture generation. Okay, let's talk a bit about this. What's the value in this? Well, clearly, although the papers claim that this is a high detail mesh generation, we can clearly see it's wonky here and there. And I'll talk a bit about why this is in a minute, but I think nevertheless, it's still very, very able to do quick iterations and quick mockups and just to sketch out something and even do variations. So I've had a friend of mine doing like full dome projection for an artist, and he needed like, I think, 50 or so teddy bears, different teddy bears. Stuff is super for this. Also, kind of like as an exercise. Again, this stuff got published, the latest paper got published like 6 weeks ago. Learn your tech early. That enables you to use the tech as an artist, to kind of use it in an originally creative way. Because I think AI is great when it comes to derivative creativity, but not necessarily original creativity. So the earlier you learn to deeply just tweak these tools, the better you get at using these tools. And do not wait for the application of the emerging tech, because with application, everything tends to go a bit mainstream, and not so hot take, lukewarm take here is the interesting stuff does not necessarily happen at the mainstream of design, but at the fringes usually. So try to be able to work at these fringes, is my hint for you. Yeah, why does this stuff look as shitty as it does? So limitations of the models. So first, the input image was not the best. We could generate better with, for example, Flux. And especially for the texturing here, the MB adapter we're using here, this works with any stable diffusion model. And in here, I just went with a standard SDXL model, which again, not the greatest quality. If you have a model that's tuned for a certain style, for comic style or for pixel illustration style or whatever, if it's tuned on your own work, by all means, use that model and it will spit out a higher quality texture. So, great pun. Why? Again, mentioned, AI is currently kind of good at everyday tasks, not only in image generation, but also in coding. It coped well with just taking 10 lines of diffuser code and adding an API to it. It didn't cope well with a recently published paper adding an API to it. And AI is very capable of derivative work. It's very capable of modifying and doing alternative, generating new stuff from data it learned. It's not so great at real, true, original creativity. And that's where we come in. And I think we are uniquely positioned to do so. Because comp-sci, especially computer graphics, has been an intersection of art and tech. So, yeah, generally I have to say advanced knowledge unlocks new tools, and I hugely encourage that for you. Here are a few tools of the trade I use in my daily life when it comes to AI or exploring that stuff and research and stuff. So typically nowadays I'm in the business of finding, implementing, and modifying papers. And finding papers is the typical Google. Perplexity is just a wrapper for a bunch of AI tools where you can upload a PDF, search through it, navigate it. ChatGPT, you know. Zotero is just your library of papers, which is really easy to generate quotations out of. For understanding papers, anyone already using Notebook LM? Just show of hands. 1, 2, 3. Use Notebook LM. It's by Google. You upload documents or URLs to it, and you can chat with the URLs. But the ridiculous part of it, and I wouldn't have thought this would work, is you can generate a podcast out of whatever you upload. And you have a male and a female voice discussing whatever you uploaded. And I didn't think this was valuable. This is by far the quickest way to understand a paper. It's super accessible. And then for implementation, you've seen my workflow, ChatGPT, Perplexity, Python, Jupyter Labs, and of course Houdini, just purely speaking AI here. Houdini for me still is a hub, still is what I most often use to work with high-dimensional data, not necessarily geometry, but any data that's more than 2 dimensions. That is Houdini. I've got 2 final questions for you, but before we go into those, one more thing. Currently, we've got our applications open for our masters. So if anyone of you thinks about getting a degree with Manu and me maybe, you can apply now until May 31st. Portfolio, letter of motivation. You need a bachelor's to start your master's with us. And then, I mean, you have to be able to take Nuremberg for 2 to 3 semesters. Yeah, which brings me to the final, maybe the most important question of this talk. The reason why I did this talk for you is, should AI content be published on Entagma? I mean, not content that's created with AI, but content like this, showing you how to use an AI, how to abuse it, how to tweak it. And please be honest, I'm super fine if you say no, absolutely not, because I'm getting very, very conflicting communication from the community. I'm seeing maybe both ends of the spectrum, so there's absolutely not, and there's positively yes. For me, it's just important to get an overview of what you think. Okay, that's encouraging. Great. Let me see what else we have. I think we're already at the end of this presentation. Do I have one more? Let me see. Yeah. And with that, thank you so much, and I'm open for questions. Yeah, sure. I think Chris has a mic there.
Hi, thanks for the presentation. Really like it.
Pleasure.
My question would be, basically, so what you showcased now was creating smaller objects. And you mentioned it was great for generating a whole bunch of teddy bears or whatever.
Yeah.
Have you ever tried this method or similar methods to create large-scale things?
No.
Landscapes or whatnot? No.
No. So typically what you have with these, the meshes that they spit out, they are typically meshed volumes. And they have a fixed resolution. Yeah. That depends on your input image. Okay. So the larger your scale goes, the worse your resolution is, in a nutshell. So in my opinion, at least these techniques that I've been researching so far, not appropriate for huge scale models or landscapes. Okay. Rather smaller scale objects. And also maybe as a side note, Hive region, for example, it outputs a mesh directly. But for example, Hunyuan, you can tweak so it outputs a Gaussian splat, which it internally generates. So basically the step is take an image, take a point cloud, make a Gaussian splat out of that, and then mesh that. And typically, if you can afford, or if you are at the forefront of this, I would advocate using the Gaussian splats because they have a way better visual fidelity than the meshes. With meshes come all kinds of problems, and AI is better at generating Gaussian splats than it is at generating meshes.
Okay, thanks.
Yeah.
Question here. Thank you. Would you elaborate a little bit more on why you would choose Houdini to work in this workflow instead of a service like ComfyUI?
Oh yeah, absolutely. So ComfyUI, absolutely great, love it. Just when it comes to working with the stuff it generates. Just want to have it directly in Houdini. And again, the step that I didn't elaborate here that I just teased is that in between those individual generation steps, you can modify your data. And typically in ComfyUI, I find that a bit awkward. That's just all.
So you can access maybe the stuff that might be in the clip, like the data that's...
I mean, you can do that in ComfyUI as well. In ComfyUI, both in ComfyUI and Houdini, currently you do that via Python scripting. So there's no gain with either or. But no, I mean the in-between kind of results. So basically, in Houdini, you take an image, pipe it through COPS, modify the image, feed it back into the image-to-mesh generator, spits out a mesh, and then, I mean, you're in Houdini a 3D tool, so you can manipulate that mesh before you spit it in, before you pipe it back into the texturing network, right? So you can add or modify, in this case, my Game Boys. Do I want to add or remove buttons? Do I want to rescale it? Do I want to add a third screen or something like that? And then just move it along. And I think that's just more comfortable doing in Houdini than in ComfyUI, in my experience.
Thank you.
Yeah, absolute pleasure. All in the front, Chris. Oh, okay, there's one more.
Hey, great presentation.
Thank you.
I was just wondering, do you ever train your own data? Do you find that quite an easy process, or
No.
are you...
Not fully training. Fine-tuning, yes. And fine-tuning is absolutely doable. That's a good process. Takes between, for example, for image fine-tuning, 10 to 40 images. And then you've got your SSCOIA, I think it's called, the scripts that you use for LoRa training, or that we use for LoRa training. Absolutely doable. Training from scratch, that's, yeah.
Just takes too long, yeah.
takes too long. I mean, there are artists like Chris Hoffman, going by the name of Ugly Stupid Honest on Instagram. He trains his own networks based on his work, but he's got like a curated, I think he's got 1,000 renders to begin with, and then generates intermediate versions of that with the help of an AI, which he then backfeeds as training data. But frankly, for me, I think fine-tuning is enough. Yeah.
Just as I walk up to the next question, how many people in here would like to see more learning material projects leveraging AI in Houdini? Okay.
Well, thank you.
Anybody not?
Thank you, Chris. Hello, Professor.
Nah, just go by Mo. That's fine.
So this question is related to FX. So what do you think, like how much AI can understand, let's say, the classic Newton physics system, and how much it can mimic, let's say, the simulation for these physics system, let's say, maybe fire and fluids?
Honest answer, I don't know, because that's not my line of research.
Yeah.
I've seen systems that approximate simulations. I'm not sure how good they scale. I'm not sure how they are trained. I'm not sure how reliable they are. It's just nothing I can comment on. I'm sorry. I'm all image generation or content generation and not simulation at this point.
We've got some good news for you, though. We have a talk this afternoon.
Right. There's one more ML talk, which is about simulation
In AI, with using ML to train simulated volumes.
Yeah.
Hey, thanks for the presentation. It was great.
Thank
Do
you.
you think 3D modeling is going to disappear in a couple of years?
Yes. No. No, I mean, there be weary when someone answers complex questions with a yes or no. I think we will see a decline in the need of certain skills. And again, that's why I asked you, how fun is it to do texture mapping, UV, reprojection, yada, yada, yada. I think those are typical skills that you want to automate. I think... Let me think about this before answering this, before I get myself in the weeds. A huge part of it will get easier, will get more accessible. Let's call it that way. Nevertheless, when you're working on specific details, I think it'll still be a valuable tool, skill to have. Also depends which timeline are we talking. Are we talking 1 year, 2 years, 3 years, 4 or 5? I think 5 years is kind of what I would feel still be comfortable to make some estimate, and I think it's not going away in 5 years. But that harks back to also some of the topics here. The stuff that you can automate, the stuff that is maybe more mainstream, maybe more derivative, that'll get automated and taken away more quicker. Versus the high-end stuff, the bespoke stuff, that will remain, my opinion, at least for the next 5 years.
Okay, thank you.
Welcome.
Just because AI can do something doesn't mean you won't want to do it. I mean, just because AI can write an article doesn't mean that you don't want to write an article. Right now, AI can write an article for you today. Yeah. But does that mean we don't write articles anymore? So that'll be the same with modeling. It's the same with just because an AI can make an entire movie. Does that mean we don't want to make the movie? So
I mean, we're getting into the weeds of this. We can form a circle here.
We should. Anyway, on to the next question.
Thank you.
Thanks for the talk.
Pleasure.
It's like getting AI to represent meshes is quite hard at the moment.
Yeah.
Do you think the future will look like move to different mesh representations like Gaussian splats, volumes?
I hope so.
Yeah.
I'm not massively attached to the idea of having a mesh or connected geometry as a surface. It comes with a shit ton of problems. Every one of us in production and rendering and rigging knows. So I would hope that we would transition to other mesh or other volumetric data representation. And I think Gaussian splats are a good alternative. Yeah.
Actually, 2 questions.
Yeah, sure.
Okay, so first question would be, how would you recommend to get started with with AI and implementing, for example, machine learning and everything in, I would say Houdini for now, because it's like my main program actually. And the second question would be, how deep do you think you have to dig into networks and everything to really get control over your results? Or would you say it's more about the prompt that you give it?
Okay, so where to start from depends on your previous knowledge, depends on what you do, what you know. I typically recommend my students to start with ComfyUI, that's been mentioned here before in a question, which is a node-based tool that runs in a browser window, standalone tool. You can have individual components of individual different AI networks. Text to image, image to video, image to 3D, etc. You just string them together. Very similar in its UI to the Blender geometry nodes, by the way. I think they use the underlying library. And I would use that and then export to Houdini to start with, to get a handle, an idea about what an AI is, what does which part. And you can already mingle around with the individual components in there pretty well. So that brings me to the second question. How would you kind of, let's call it, elevate this above your standard prompt? Yeah, is that the question? Okay. Yeah. I mean, yes, prompt engineering is one way, but typically the interesting stuff happens after your prompt gets converted into what's called embeddings. And that is, let me get back to that was the colorful nebula thing that I showed you. This is basically text embeddings, the concepts that I've shown you there. Jesus Christ, I have slides there. How about we start? Yeah, exactly. So these are embeddings, and they typically don't live in 3 dimensions. This is projected down with a process called UMAP. They typically have 768 dimensions, so we cannot imagine this. But it's just, and we don't know what the AI thinks which axis is what. Is it catness? Is it cuteness? Whatever. But typically, it's just a list of 768 coordinates. You don't have just X, Y, and Z, but and you just start modifying these numbers and see what comes out of it.
Okay. Thank you so much. Thank you for the talk. It was
Absolute
amazing.
pleasure. Thank you.
More questions. And while I walk over, I'll tell you about an event that we're going to host in London that's going to be focused on Houdini using AI, next-gen technologies, things like Gaussian splatting, things like machine learning. So October 6th in London, if you want to put that in your calendar and then join us there.
Hi, thank you for the talk. Have you looked into retopology? No. Because I guess the mesh is quite random.
Okay, so, I mean, of course, I tried throwing it into the quad remesher in Houdini, which is so-so results. Typically, my automated go-to would be Z-remesher. I haven't tried it with that yet, but I think it's a good base to start, to throw it in there. Yeah.
Thank you.
Again, I'm more of the opinion, or I'm more convinced that Gaussian splats, at least at the current state of these models, Gaussian splats are the better, higher visual fidelity representation of the data they spit out. But not every pipeline is built for that, of course. Yeah.
Awesome. Great stuff, Mo. Thanks for sharing.
so much. Thank you, everyone.